Alright guys, here's the second part of our chapter 2 review. Okay, so we are on the back page now. Here we go. 11, 12, and 13 are just more or less things to kind of think about for the upcoming test, not as opposed to like things you gotta like actually do practice problems for. You should know how to calculate slope, determine it's rising, falling, horizontal, or vertical. By the way, slope formula as well as any formula in class will be provided for you on all assessments. Okay, they'll be on the front board, they'll be on your test, whatever it may be. I don't really ask you guys to memorize it, just know how to use it. You should know how to draw a scatter plot and then determine whether a graph has negative correlation, positive, or relatively no correlation. This is the little calculator work that we did the other day in class when we did entering in all the points, finding the line of best fit. That's all we're talking about here. So that's nothing too bad. And you should know everything from chapter 1 as this is a cumulative part of the test. Basically, this is a cumulative test from chapter 1 too, so you have to know both. But this was just chapter 2 stuff. Here we go, 14 through 16. Write an equation of a line in slope-intercept form that has the given properties. Has slope of 2 and passes through the point 1, 3. Here's our slope-intercept form, y equals mx plus b. Slope is m. This is an x and a y. We're going to plug everything in, and we're going to find our y-intercept, then make an equation up. So for y, it's 3, getting that from right here. Our slope is 2. Our x is 1. And now we're solving for b. Well, all we got to do is subtract 2 over. b equals 1. Not quite done yet. Let's go ahead and make up our general equation. Y equals mx plus b. Our m is 2. And our b is 1. Good. Notice that we didn't put anything in for x and y because we want to leave them x and y so that we can make up generalizations for later on. So like now we have an equation. If you ever want to know what y equals when x equals 10, plug a 10 in for x and you can solve for y. So that's why it's very nice. 15 passes through 4, 6 and is parallel to y equals 1/2 x plus 7. These two concepts here are really important. You learned them last year in geometry. Parallel slope. Okay, so if I look at this equation or line, the slope is 1/2. Well, parallel slope is exactly the same. So our slope is 1/2. Okay, parallel, same rate of change, real simple. So I'm doing the same exact thing over here as I did. Well, I'm doing the same thing as I did in the previous problem. Here's my x and my y. We're plugging things into y equals mx plus b. Y is 6. M is 1/2. X is 4 plus b. Half of 4 is 2. Subtract 2 over. B equals 4. So y equals 1/2 x plus 4. All good. Okay. Again, same type of problem, just we have to recognize the slope. Now, the last one, perpendicular. This is the one that throws people off every now and then. Passes through 3, 2, and is perpendicular to y equals negative 3x plus 2. The slope for this line is negative 3. Perpendicular slope is opposite reciprocal, meaning we're going to flip this and we're going to negate it. So since it's negative, it becomes positive, and when we flip 3, we get 1 over 3, because technically every number is divided by 1. So here's our new slope, 1/3. Okay? Back to what we've been doing. Y equals mx plus b. Y is 2. M is 1/3. X is 3 plus b. It's kind of nice because 1/3 of 3 is 1. Subtract over, b is 1. Plug everything back in. Y equals 1/3 x plus 1. And we are awesome. Okay? So, very good. Last part of graphing here. 17 through 19, you do have the option to do on the graphing calculator. There is an absolute value button. Okay? And I will show it to you in a moment. But it's basically in this form. Y equals a, absolute value of x minus h plus k. We're trying to find our vertex. Okay? And our vertex is the x value anyway, is the opposite of the number to the right of x underneath the absolute value sign. And our k is the number tacked on the end. So what's the opposite of plus 3? Well, negative 3. And then since there's nothing out here, that number represents as 0. So our vertex is negative 3, 0. So to the left 3, 1, 2, 3, and then up not 0 is right there. Now, the next part is finding our slope, which is the a in front. Since it's negative, just a negative sign, that means it's negative 1. All we're going to do is our slope is -1, we're going to go down 1 over 1. And as we're going to discuss in class, the absolute value graphs are all V-shaped, okay? So once you have that 1 point plotted, we're going to flip it across our line of symmetry. And now we have all the points we need. Okay? It's really quite simple once you do a few of these. Now just to show you via graphing calculator, here's y equals. Alright, so it's negative absolute value of x plus 3, the negative sign first. Now I'm going to hit the math button. And I'm going to go to the right one, and it says ABS, abs. Hit that, that's your absolute value. And I'm going to type in x plus 3. Okay? Once I hit graph, boom, there's my same graph I got there. Again, you can pull up your second graph. And you'll notice that, again, it all revolves around -3 because that's our vertex. Okay, everything opens up around it. So -1, -1, -2, -2, so on. Okay? You may use a graphing calculator. I'm fine with that. I think these problems are actually easier without it. That's just me. Yes, I know I'm a math teacher, but you get the idea. 18, y equals absolute value of x minus 2 plus 1. Vertex, opposite on the inside, same on the outside. So 2, 1. And my a is number out front. If there is a number, your a is 1. So vertex is 2, 1. To the right, 2, up 1. My slope is 1, so up 1 over 1. Draw your line of symmetry if you need to. Flip it across it. Play connect the dots. Give yourself a high five. Okay? Very nice. 19. Y equals 2. Absolute value of x minus 3. You'll notice for this one, for my vertex, I don't have a number next to x inside the absolute value bars. So that means it's 0. And it's same on the outside, so -3. This time my a is different. It's 2. Okay? So 0, -3, down 3, 3. My a is 2, which means slope of 2, up 2 over 1. Flip it across your line of symmetry. There you go. All right. Please make sure when you're doing all of these, all right, again, you can either draw a table out, or you can just make sure your points are highlighted like I have here. Okay. I'm fine with either. Just don't make me guess. That's all I'm asking for. Like, I mean, just don't just draw a V and be like, oh, that's okay. Just make sure everything's labeled correctly. Alrighty. All right. Everybody's favorite, piecewise. All right. For as far as these go, I'm not going to have a ton of these on the test. You might have one of them. These are probably the most difficult part of the entire exam, I think, for many of us. Piecewise functions is just basically 2 lines on one graph. You're splitting it up. So this one's saying x minus 2 when x is less than or equal to 0, and x plus 2 when x is greater than 0. All right. So 0 is my break right here. So let's look at our first one, x minus 2. The y-intercept is down here at -2. Because it's less than or equal to, I'm going to do a filled-in line, filled-in dot. And my slope would be 1, so I'm going to go up 1 over 1. But notice how it's less than or equal to 0. So I'm going to, instead of going up 1 over 1, I'm going to go backwards. Okay. And my graph is just everything to the left of it. So this is line 1. Here's line 1. And that's what the line x minus 2 would look like if I continue it this way. But I only want everything to the left of 0. Alright? Now, for my second one, x plus 2. My y-intercept is at 2. Notice it says greater than 0, though. So instead of a filled-in dot, I'm going to do an open dot. And then my slope is 1. So I'm going to go up 1 over 1. And I only want everything to the right of 0. Okay? There's a piecewise. Now it's a little simpler than, most of them, but for the most part, that's what it should look like. You have a break in your line. Okay, so I have 2 lines going on here, but you only want certain parts of it, certain domains. Okay, don't stress a whole lot about that because we're only going to have like 1 question on the test about it, but we'll make sure that you guys are confident before we get there. Okay, cool. Last part. In a certain city, the amount of property tax paid varies directly with the assessed value of the property. If the family whose house is assessed at $90,000 pays $2,700 in property tax during a certain year, what's the assessed value of a house whose owners pay $1,850 in taxes during the same year? Now, there's two ways to do this. I'm just going to share with you guys the one way I think is a little simpler. We're talking about comparing two things, so we're going to create a proportion. The people that pay $90,000 a year have a property tax of $2,700. So we know that has to be the same rate, okay? It's why it says varies directly. So the same constant of change there has to be, okay? Or constant, not constant of change, it's constant in general. So what they're saying next is, what's the assessed value of a house whose owners paid $1,850? Well, I'm going to put $1,850 in the bottom, and then I want to know what the value of that house is. I don't know it, so I'm going to call that X. Well, now I have my proportion set up. Let's just do some cross multiplication. 2,700x, x times down low, and then 90,000 times 1,850 gives me a very large number. Okay. Hang on one second. 1, 6, 6, 5. 1, 2, 3, 4, 5. Cool. All right. Now, I'm going to take this number, divide it by 2,700. Ooh, that's not good. There we go. Okay. X equals 61, 666, 67. Okay. So, not too bad. Again, notice that when I first did that in the calculator, I got a really, really large number, and I thought something was wrong just because I accidentally multiplied it up here when I should have divided. So it's a good way to self-check as well. I did that on purpose, obviously, because I, never make mistakes. But yeah. So, all right, guys. Again, if you have any questions, feel free to ask in class. I'm hoping this has helped so far. Keep up the good work. And as always, good luck. We're all counting on you.